we now demonstrate how to use Excel to run multiple regression on the heating cost case. In this case, we have the heating cost as the dependent variable. We have three independent variables: temperature, insulation, and furnace. Let's call the multiple regression model. We are going to go to data analysis, and we find the regression in the analysis tools. And we say, okay. In the input, we have the Y range, which is the dependent variables. So we are going to include all the dependent variables data, heating cost, including the labor, into the Y range. For the X range, which is the independent variable range, so we are going to include all independent variables and their data into the X range. As you have seen, I have included the labors into the input, so I'm going to click on labors. This is recommended because including the labor into our analysis will allow us to see what is dependent variables and what are independent variables in the output. About the constant is 0, this is about 0 intercept. Most of the time we leave this empty because we are not sure what should be the intercept value. Unless you are 100% sure that the intercept should be 0, you click on this item. Otherwise, we leave this empty. About the confidence level, by default, it is 95%. Most of the time, we don't have to change it. But if your research requires you to set a different confidence level, you can change this value to a different value. For example, 99%. But as I said, most of the time, we can leave it like it is, and we can use 95%. It really depends on case by case, what kinds of research you are doing and what kind of requirement standard you are using. So we can, whatever value, 95 or 99 is okay for today's video. For the output, you can generate the output into a new sheet. Given that our data is relatively large, I'm going to output the data, the output data into a new sheet. We can also change the residual choices. Given that this is not the focus of today's video, so I'm going to leave them empty. So I'm going to say, okay. In the output, you can see, let me change the name to output. You can see 3 tables here. Let me enlarge them a little bit. The first table is about the regression statistics. You can see the value of R-square, adjusted R-square, standard error. For the ANOVA, you can see the F value and the significance level of F. That's the p-value of the F test. Today's focus is on this coefficient table. I'm going to highlight that in a different color. More specifically, we are going to look at this coefficient. So again, I'm going to make a different color. Based on this output, we know that the intercept for the multiple regression model is 427. The coefficient for the temperature is negative 4.58. The coefficient for the insulation is negative 14.83. And the coefficient for the furnace age is 60.1. Based on the coefficients, we can write down the multiple regression linear model, which is equal the 427, the intercept, plus negative 4.58 times temperature plus we have negative 14.83 times insulation plus 6.1 times furnace age. Of course, you can further improve the equation. For example, you can say furnace age, right? And insulation, that would be thickness, right? And you have the temperature, outside temperature. So it's kind of small detail you can improve. For example, you don't have to have parentheses here. You can just have negative 4.58. You can just have negative 14.83. And this will give us the multiple regression model we need for this heating cost case. Okay, so you can also open this Excel file and follow my procedure to run the multiple regression by yourself. Good luck. Thank you.